you for inviting me to speak. My problem is that I've been making so many notes on what everybody said, I can't read what I originally wrote I was going to say. But what you just said is absolutely spot on. You have to understand about the structure, the governance structure, and where the device is coming from. And it doesn't matter how great the experts are. In fact, it might matter even more if you get two great experts and put them head to head. You're quite right. You will get all sorts of interesting and difficult issues to deal with. The other point which has just come up, which is about science and policy and the difference between the two. Science is the servant of policy, and I say that as a scientist and an engineer. It is because you have to take decisions. I can't remember who the speaker was who was talking about climate change, and yes, you said. That's right. Talking about having to take a decision, right? I couldn't agree more. Although I am, as I say, scientist and engineer, right, all the way down to inner parts of my body. You know, I absolutely believe in evidence. I believe evidence is really important for taking informed decisions. But that is not the same as being a politician or a policymaker. Because a politician or a policymaker has to take decisions and has to look at what might be conflicting advice, especially if you have two eminent experts, and you cannot afford the worst thing to do is to not to take a decision. Okay. So we recognise that science and policy, in that sense, have a very strange relationship. One of the things that you might get told, or that people might say, is of course what you should do is somehow have somebody with expertise, science advice, and somehow that gets the policymakers nod, and then all will be well, and it turns then into good policy. Nobody in this room who has had any experience whatsoever of science and technology advice recognises that linear model of going from science to policy. It never, never, never happens like that. And yet you can read in book after book and in a lot of academic approaches this model of how things ought to work as opposed to the way things do work. So how do things work as opposed to how we would like them to work? Because it's better to start with human beings and how they operate and then build up from there. Well, why are we sitting in this room? We're sitting in this room because we're exchanging ideas. When I was asked by the University of Cambridge about 4 years ago to start the Centre for Science and Policy.
Why not science policy?
Because we go one direction. We go from science and technical advice to policy. This is not about policy for science. Okay? So I just go that way. There are other experts who can tell you about the journey that way. Okay? I will tell you about how that particular direction. So I was asked to do science and policy. And it followed a very successful series of a series of meetings where we brought permanent secretaries and occasionally some senior politicians from London to tell them about a particular topic. Genetic engineering, space flight, migration, obesity, cloning. All of these were topics which at that time were very leading edge. A lot of people know all about those topics now, and we're familiar, we read about them in the papers. But the idea was to take people from the science all the way through to the policy implications. And it started with the academics and gradually handed over to the policymakers by the time you got to the end of the day. Now, that's a model which worked very well at that particular time in those particular circumstances. The reason why what I do now, and I'll explain a little bit about it in a second, the reason what I do now is that we in the United Kingdom have a network of chief scientific advisors, which is partly as a result of those meetings. It was decided that that science advice needed to be more deeply embedded into government. And people have less time. People are very busy. And I'll get on to some of the other things that go on, for example, about open innovation in a second, because that's another part of this process that's changing in the way that we operate, in the way that politics operate, in the way that you have to incorporate not only what governments can do, but also about the private sector. So I used some of the experience that I'd had in doing some other things. I helped found a thing called Cambridge Angels, which we fund companies in Cambridge. There are about 55 of us, and I was chairman of that. That is a networking organisation that operates at Cambridge and helps fund new startups. I helped found a thing called Cambridge Network, which Cambridge Network has 1,400 members, individuals and mostly companies, and we exchange views about what is going on in Cambridge, and we also have a training arm which allows companies to buy training, and we design training courses to help companies in Cambridge. I started Cambridge Wireless, which is a networking organisation based in Cambridge, surprisingly enough. About 400 members, includes all the big names, and that has a very different structure. We have special interest groups that meet once or twice a year and exchange ideas.
Why is it called wireless?
Why is it called wireless? Because it is all about everything you can do with radio systems. Okay? Cambridge has a relatively long tradition in radio systems, and is one of the great clusters in radio, as it is one of the great clusters in biotech. Now, all of those things taught me stuff, right? I began my career as a consultant, and consultants have to get business, they have to talk to people. I noticed that actually talking to people tended to lead to business, but it also led to interesting conversations and all sorts of things like that. And I also noticed that when I started these networking organizations, if I gave a lot into this network, a lot of good things came back. Not necessarily in terms of commercial gain, but just meeting interesting people and doing interesting things that you would never otherwise have had the chance to do. So an economist is somebody who sees something working in practice and can't help wondering if it works in theory. And so I thought, why does this work? It's one of these obvious questions. It works. We all, we network together here. We know other people. Why does this work? What is actually going on? And it turns out that actually, if you want to dig into the mathematics of this, there are actually some very good reasons for the way in which networks actually work. Everybody's heard about 6 degrees of freedom. I first read about that as an experiment when I was in the 6th form at school. So I was 17 when I read that. So that is a long time ago. And so 43 years ago, okay, when I read about it.
What is a 6 degree of freedom?
Okay, the 6 degrees of freedom the 6 degrees of freedom was a very interesting experiment. Somebody in the United States was given an envelope. There was no address on the envelope, although there was an indication about the person and what their trade was, so you could make a guess that they might be an architect. And what you might do then, if they saw they were an architect, you might pass that to a friend of yours who was an architect, who would then pass it on to the next most likely person. Right? And on that went. The average number of hops between the population of the United States, which at that time was 230 million people, not 300 million people, 230 million people, the average number of hops to get from the origin to the destination was 6. That's all it took. And that was, now in a network, in network theory, this is a directed search, but you don't know the shape of the whole network, you don't know who's in the network, you don't know how they're all connected, but you just try to go from node to node until you have found the target. Okay? That's what 6 degrees of freedom is originally about. It's slightly different these days when people talk about it, but everybody is connected. I guarantee that I am no more than probably 3 hops away from every single person in this room, including all the people that I've ever met. Yeah, we discovered that.
We discovered that.
We have people in common, right? And hadn't met Mihaela before. We have people in common. I guarantee. I guarantee there is nobody. Given that I'm standing in this room, I pretty well know that there's probably no more than 2 people between me and everybody in this room. I know somebody who knows somebody who knows you.
That's what I know.
Okay. We all know Mihaela, so in fact actually there's only one. Now this is an important point, because Mihaela is a supernode, right? Mihaela is very well connected. If you want to do something, and you wanted to do something in this topic area, where would you go to? Well, I would go to Mihaela. That's natural, isn't it? Because she knows everybody. She can put you in touch with everybody. She can get things done. Okay? So we observe this. What is really going on? Well, I'll do a little bit of just a little bit of description of mathematics for a moment, because this is quite important to understand. What you find is there are some people, a few. If you took everybody you knew and you drew a graph of this person knows the most people, this is the second most, third most, fourth most, fifth most, you would have a nice little straight line as it happens, in the ratio between one person knows 30% more than the next person, and that applies all the way down. At the top end, there are people who know thousands of people. If you get to them, you can get to everybody else in the network. Now let's go back to science advice, because this is a really important issue for how do you get science advice spreading into government. Well, the answer is not to get somebody who is an absolute expert in their field who has no friends. On two counts. One, they probably have no friends because they're a bit difficult to deal with. And the second one, and more important, is that they don't act as a gatekeeper to all the other advice that you actually need. If you look at the problem that the UK had at the time when we had the BSE crisis, that is the mad cow disease problem, the issue at that point was not that we didn't have available the scientific advice about what to do. It was simply that the people who were giving that advice were closed up and were not well connected to give a broad spectrum and a broad reach. Okay? Now, a lot of work actually has been done without thinking about the theory, about how this can change. And one of the things that I've been doing at the University of Cambridge is to try and build a network that does the stuff without you needing to really push or work hard. So this is a wonderful solution. I'm an engineer, by the way. I like to do things for the least possible effort, right? Engineers are basically very lazy. They design systems to do work for them at the lowest cost and with the least possible effort. So what we do is we bring in civil servants for 5 days to Cambridge. Those civil servants provide us with a list of questions that they want to talk about. From that list of questions, we then identify academics at Cambridge and at other universities, and perhaps some companies as well, private sector, who they should talk to. And we identify those people that they should talk to, not on the basis of a narrow definition of the answer to the question, but on what is going to be really interesting and might throw up something unexpected. We have now, just to give you some numbers, around about 110 of these policy fellows. They occupy many of the senior levels in government, and you will be talked to by, unsurprisingly, one of our policy leader fellows, Jeff Mulgan.
Yeah.
Is one of our policy leader fellows, and in fact he came up to Cambridge last week, it must be last week, to have a discussion with us and attend a workshop and attend a dinner with other people to do that network. So we have built a formal network, because it is formal, we have policy fellows, But across that formal network, a few interesting things happen. Firstly, if people in government need advice, we have provided a very broad pool from which they can draw that advice. They can not only go direct to the academics, they can also now go to their other policy fellows and ask them if they know somebody who would actually be able to answer a particular question. The result of that is we know that the communications that flow across that network have changed government policy in the United Kingdom on a number of occasions, including material that was in the Chancellor's autumn statement.
Such as?
Now I'll get you on to the next bit. Okay, very important. We are not doing this as open public activity. If you want to do science democracy or policy making that's open policy making, that is a different thing. And I fully support it. It's a very good thing to do. It's very important to have people involved. But what we are doing is providing a network that allows information and knowledge, understanding, contacts to be made as quickly and efficiently as possible. I don't know where this...
level.
Sorry?
Boardroom level.
Well, no, we have junior policy fellows, so we'll have young fast-track civil servants, like Mitchell Harris, who was at the Ministry of Defence and is now working in the Cabinet Office. He's 27, I guess, something like that, 26. We have Director Generals, level 5 in our civil service. I don't know how everybody else works, but people who are kind of mid to senior-ish people who are probably everywhere in the world. They're the people who are mostly making the policy. Then we have the policy leader fellows, who are the people at the top, the director generals, the people who are running ministries, and those are the people who, and we have separate cadres for those, so they can network together. So we cover everything. I'm so way off what I was going to say here. The point about this is that once you understand how networks work, and once you understand that everybody is very close, and you understand that there are some supernodes, you can actually help create supernodes. You can actually help allow people, like our policy fellows, to establish lots of connections that will then serve them well in their job, in what they're supposed to be doing. And now I get on to some recommendations about science advice. If you want a good scientific advisor, the good scientific advisor has to be trained in science, because you don't want somebody who doesn't understand the scientific method, or has to be trained in engineering. They have to be a STEM subject of some kind. Otherwise, it's very difficult for somebody coming from history or languages or whatever to understand, or politics and philosophy. Well, philosophy is not bad, actually. Philosophy will teach you quite a lot. But the difference between science and policy is so great, as I described at the beginning. You want to start with people over on the scientific side. But they don't hold the answers. They are the people who have to have access to the network. And so what you want to do is have people like that who are good at networking, who can then go and get the answers, and not just from their friends, not just from the 6 mates who they might go and drink a beer with, but from a very, very large pool that they maintain, hundreds or even thousands of people that they know about. And it's that breadth which is really important. I just want to say a little bit about, just very briefly, about policymakers and open systems. That is almost an open system, but it's not quite. It differs from a truly open system in the sense that if it were truly open, then you would be soliciting input from everybody in the general public, in the same way that Wikipedia solicits expert advice, of course, but it's solicited from the external. It is not a replacement, and I don't think either is a replacement for the other. open systems, open policy making is very important as part of a democratic process, but in order to get the scientific advice and take some of the hard decisions, I go back to my point about not talking about what the decisions were or what the particular policy outcome was. It's very important because the policy makers, the politicians, have to be protected in a sense, and so do the communication channels and the people giving the advice. You want to make sure that nobody is in the press able to write headlines about the stupid decisions or the stupid advice that is being given, or really bad, that the advice that was given was not what the policymaker then decided, right? Because the policymaker has to be free to ignore the advice, right? It is really, really important. I'd say two more things very briefly. Serendipity. My favourite word. I was going to say in the English language, but of course serendipity isn't really English, it comes from Sri Lanka. And it's about trying hard to do things and good things happen. And that's what networking is about. And networking really works when you put more in, as I said right at the beginning. With the technology that we've got, the fact that I can carry around in my iPhone, all the gadgets and communications technology that you would have previously had 3 or 4 suitcases to carry, enables you to do networking at a level that was previously impossible, and at timescales that were previously impossible. We are changing the way in which we are governed. We are changing the way in which we involve people in the policy decisions. We are changing the way in which we can network. We should acknowledge all of that. We should be building networks ourselves so that we can do things like get the best policy, engineering, technical advice into government. But don't let us confuse the fundamentals. Don't ever let us think that science and evidence advice substitutes for policy making. Those two things are different. Thank you very much.
There one very immediate thing that you probably did behind the scene was to welcome the new chief science. What is he called? New
Chief Scientific Advisor.
Fine. Katy probably knows about it, about that sort of thing too. There was in April, 14th of April.
Yep.
There was a change of the new government scientific advisor in this country, and something which was quite extraordinary was that there was one day which prepared him, to listen to a number of these things, including the issue of networks and all the rest of it. Why did you do that? There were about 6 months or 4 months in advance preparations for him to listen, and then the other day he chose Cambridge to come and talk about the IPCC report and Britain. So he's attracted to your network, or you attract him? Which one?
Well, okay. I'll wind the clock back a little bit. We had the previous scientific advisor, chief scientific advisor, up to Cambridge, and he'd not really heard of the Centre for Science and Policy because we were quite new. But in his speech he said, I asked my staff about the Centre for Science and Policy, and I found that 3 of them were already policy fellows of the Centre for Science and Policy. Okay. So we had already established within the scientific advisory community a real presence. It happens, I don't think this has anything to do with it, but on the 6 degrees of separation, it happens that Mark Walport, who is the chief scientific advisor, is a very good friend of a friend of mine because they both live in Putney. But that's just part of how small a world this is. The real reason I think for doing this was that we had our annual conference at the right time. It's always good to have a coincidence like that. And we had as Mark Walport's chief of staff, somebody who was also somebody that I had worked with on foresight programs before, and therefore we were able to go to her and to say to her, we're doing this annual report, we would like to do something really significant. I mean, there are some very interesting essays in there, and I'd recommend Jeff Mulgan's one, for example, right at the beginning, about how scientific advice gets put into government and how perhaps it should be and what the issues might be. And it was really quite obvious, I think, to the incoming Chief Scientific Advisor at that point that this conference was a good platform for him to make his first speech. And if you want to see, there's a video on YouTube of me interviewing Mark about precisely all of that. But so the reasons for it, let me just try and summarize. The reasons for this are because we had established a network which was already working, communicating about scientific advice. And Mark Wolpert, who comes from a business background as head of the Wellcome Trust, as a chief executive, understood the power of networks and was very happy then to reinforce it.
Thank you.